Hi everyone, this is Divyang Khandelwar from Division Math Academy, and today we are going to start with trigonometry where we are going to cover trigonometric basic, ratios, trigonometric of obtuse angles, sine rule, cosine rule, and area of triangle. Now, it's a revision video, so we are going to do everything quickly. So it's not a long course. So let's see how we are going to figure it out. So we're going to start with trigonometric ratios. Now, ratios means what? So ratios means something about something like A by B, C by D, E by F. All these are ratios. Like for example, if we talk about numbers 3 by 4, 5 by 7, 6 by 5 and so on. So these are basically your ratios. Now trigonometric ratio means what? Where it will be with respect to triangle, and that is also right angle triangle. Now let's consider this triangle ABC, which is a right angle triangle, and the angle is 90 degree at B. Now if this is theta, so now the ratio of the opposite side to the hypotenuse, so of course this is going to be the hypotenuse, which is going to be the longest side. So the ratio of AB upon AC is something. Then the ratio of BC upon AC is something. And the ratio of AB upon BC is something. Now all these ratios we have given the name for these things. So AB upon AC, which is nothing but opposite. This is the side which is opposite to this theta. That's why it's going to be opposite upon hypotenuse. This is going to be adjacent upon hypotenuse, because as you can see, BC is adjacent to this angle theta, and opposite upon adjacent. And these are your three main trigonometric ratios, which are sine theta, cos theta, and tan theta. Now, the thing is, if we consider any other triangle like this, right angle triangle like this, somewhat, just a second, it's going to be somewhat like this, and any other triangle like this. Okay, so let's consider this is ABC and this is PQ. So as you can see, triangle ABC and triangle PQC, these both are right angle triangle, and as you can see, this angle is theta. Like this angle, I've just mentioned this angle is theta. Now the ratio of PQ upon PC, like this PQ upon this PC, will be equal to the opposite side, that is AB upon AC. So of course, we are not taking in detail. So right now, just understand that the ratio will always remain same. Like maybe if this is 1 and 2, this is going to be 2 and 4. I'm talking about the other ratio. At the end, 1 by 2 is equal to 2 by 4. So the ratios are always going to be same. So that is basically trigonometric ratios. Now, for example, let's consider this is the triangle. And let's say this theta is 30 degree. And let's say the hypotenuse is 10 centimeters. And we need to find this ABC. We need to find this AB and BC. Now see, the information is not enough. I mean, as we can say, it's only 10 centimeter they have given. We need to find AB and BC, but they have also given the angle. So using trigonometry, we can find AB and BC. Now, because we know sine theta, cos, like sine 30, cos 30, and all the angles basically, all the trigonometric angles. Now, if we consider sine of 30 degree, that's going to be what? That's going to be opposite. That's why AB upon hypotenuse, that is AC. Now we know that sine 30 is half. So we can substitute 1 by 2 is equals to AB. AB is what we need to find, and AC is 10. So basically, as you can see, AB is going to be 10 by 2, which will give me AB as 5 centimeter. So these are the basic questions they can give you. For example, if they ask you to find BC, so we know that cos 30 is going to be adjacent. That's why BC upon AC, which is nothing but, which will give me cos 30, and cos 30 is nothing but root 3 by 2. So root 3 by 2 is equal to BC. That's what we need to find upon AC, which is given 10. So the value of BC is going to be what? BC is going to be 10 times root 3 by 2, which is nothing but 5 root 3. So that was the basics of trigonometry. Now this we can use only when the angle is from 0 to 90 degree. But what if the angle is above 90 degree? Then we cannot form a triangle with one angle as 90 degree and the other angle more than 90 degree like this. So it cannot form a triangle. So that's why we cannot use that approach. So for that, what we will do, we will construct a circle on the coordinate axis. So let's consider these are your x and y axis, and this is a circle. And this is the radius of the circle, which is r. Now, as you can see, this is going to be the right angle triangle. Let's say this is O, this is A, and this is B. And the coordinate of B is x comma y. And this is the angle theta. Now, according to the traditional definition, like basically opposite upon hypotenuse and all those things, we can get sine theta is equal to opposite. That's why opposite is going to be AB. Now, as you can see here, this AB is nothing but your y coordinate, and this OA is nothing but your x coordinate. So that's why your sine theta is going to be what? It's going to be opposite. That's why y upon hypotenuse, that's why r. Because r is the radius, that's going to be your hypotenuse. Similarly, cos theta, if you see, cos theta is going to be adjacent. That's why x upon r. So this is your sine theta and cos theta. Of course, now see, the thing is tan theta is nothing but sine theta upon cos theta. So our main trigonometric ratios are sine theta and cos theta. Okay, from that we can determine all the tan theta and everything. So our main ratios are sine theta and cos theta. So we got sine theta as y by r and cos theta as x by r. Now what if the angle is more than 90 degrees? So it will come somewhere here. Okay, now let's say this is point C, and the coordinates be x dash comma y dash. But as you can see here, the coordinate is in second quadrant, right? This is the second quadrant. So in the second quadrant, x will always be negative. So it's going to be minus x dash, whatever we can say. And y will always be positive because it's going up. So it's going to be minus x dash comma y dash. So instead of writing x dash y dash, what we will do, we'll just write minus x dash and y dash. Okay, just name. So this is going to be C. Now, according to this thing, if this is the angle, like we are actually asking this angle, which is going to be, let's say, angle alpha. So basically, this time your sine alpha is going to be what? Sine alpha is going to be opposite upon hypotenuse. That's why it's going to be opposite is going to be how much? It's going to be y dash upon r, because the radius is same of the circle. And if you talk about cos alpha, it's going to be what? It's going to be adjacent. That's why this adjacent side, which is nothing but your minus x dash, which is nothing but minus x dash upon r. Now that's why, as you can see, the sine will be positive, but the cos will be negative. And this we will use it for our problems. So for example, if they ask you what is sine of 180 minus theta, it's going to be simply sine theta. But if it is cos of 180 minus theta, it's going to be minus cos theta. Because on the first quadrant, sine and cos will be positive, but on the second quadrant, sine will be positive because it's a y coordinate, and cos will be negative because it's an x coordinate. Now see, again, I'm telling you, I'm not taking in detail because it's a revision class. If you want in detail, let me know in the comment section. Then I'll explain you this thing in detail. Anyways, so this is sine of 180 minus theta, and cos of 180 minus theta is going to be minus cos theta, and sine of 180 minus theta is going to be sine theta. Now, examples. So for example, if they ask you sine of, let's say 110 degrees. So it's going to be what? We can write this thing as sine of 180 minus 70. So this value is going to be what? It's going to be sine 70. Like definitely, be it sine, be it cos, it's going to be 70. But the sign, or I'm talking about the plus minus will be dependent on this thing, whether it's a trigonometric sine ratio or cos ratio. Now here it is sine, that's why it will stay positive as it is, sine 70. But if you talk about cos of 110 degree on the same side, so this is going to be cos of 180 minus 70. Now cos of 180 minus 70 is going to be what? It's going to be cos 70, but it's going to be positive or negative. So as you can see here, cos is basically a function of x, like function as in it's a ratio with respect to x coordinate, and in second quadrant x is negative, that's why it's going to be minus cos 70. Okay. Now, if you talk about tan 110, tan 110 is nothing but sine 110 upon cos 110, which is nothing but, which is nothing but tan of 110, and sine of 110, we just figured it out. It was sine 70 upon cos, cos 110 was minus cos 70. So our final answer is minus tan 70. So that was the relation we found. So in short, tan of 110 is nothing but 180 minus 70. And here also it's going to be minus tan 70 because of the cos here. Okay. So that's how we can figure out the obtuse angles, trigonometric obtuse angles. So let's say one more example. So sine of 135, for example. Now sine of 135 is nothing but sine of 180 minus 45, which is nothing but sine 45. And it will stay positive because it's sine. Sine will stay positive in second quadrant. Cos will stay negative in second quadrant. So this is going to be 1 by root 2. That's it. Okay. So this was all about sine and this thing like obtuse angle. Now area of triangle. Now we can use trigonometry to find the area of triangle. For example, if we have a triangle whose angles are A, B and C, and the side opposite to angle A is A, side opposite to angle B is small b, and side opposite to angle C is small c, then area of triangle is going to be what? Area of triangle is going to be, say, again, I'm not going to give you the proof, but I'm going to give you the technique from which you can remember. So area of triangle, generally we know half into base into height. Always we use that. So we're going to use the same thing. It's going to be half into base. So just consider any of the sides, A, into the other side, let's say B, and multiplied by sine, since the area of triangle is based on sine itself. So it's going to be sine of angle between A and B. So angle between A and B is what? It's angle C. So that's why it's going to be angle sine of C, basically. Also, it is equal to, you can consider other two sides as well. It's going to be half into B into C into sine of angle between them. Now, what is the angle between B and C? B and C, sorry, it's going to be A. So it's going to be sine A. And area of triangle, again, it's going to be half into A into C into sine of angle between them, which is going to be sine B. Now see, the thing is how you can remember that we have to give importance to each element. So that's why we are giving importance to A as well as B as well as C. Here also B, C, A. Here also A, C, A. That's just a way of learning. Okay. So for example, let's say we have a triangle like this. Of course, we don't know the height of this thing, but we know this is 10, this is 15, and let's say the angle between them is 45 degrees. So the area of triangle is going to be what? Area of triangle is going to be half into 10 into 15 into sine of 45, which is going to be, you can cancel this 2 with 5. So this is 75. 75 into sine 45 is nothing but 1 by root 2. You can put it in the calculator and you can get the value. So that's basically 75 by root 2. If they ask you in third form, you just multiply by root 2 and root 2 divided by root 2, which is going to be 75 root 2 by 2. This is basically a rationalizing thing. They may ask you. Okay, so this was the example of area of triangle. Now, what about sine rule? So now let's consider the triangle this. Again, this is A, this is B, this is C, this is angle A, this is angle B, and this is angle C. I'm just writing down in a different way. Now, sine rule is quite simple. It is the relation between angles and side. So it is basically sine A upon A is equals to sine B upon B, which is equals to sine C upon C. This is your sine rule. So on the other hand, you can write like this also, of course, A upon sine A, which is nothing but B upon sine B, which is nothing but C upon sine C. It's quite easy. So this is generally used when they give you angles, like they concentrate on angles more. So if you get all the angles of a triangle, even if you get two angles, definitely you can get the third angle. So if you know all the three angles and they have given you just one side, you can figure out the other two sides. For example, let's consider this triangle. Let's say this is 45, this is 30, 30, sorry. This is 30. So the remaining angle is going to be how much? Of course, it doesn't look like, but just consider. So 45, 30, 75 is going to be 105 degree, for example. So this is what the triangle we have. Now, for example, they have given that this is, let's say, 10 and this is 15. Not 15, this is 10 they have given. And we need to find this side. Let's say this is x and this is y. So now what we will get the ratio of this side, that is 10 upon sine of 30 is equal to side upon that angle, which is equal to x upon sine of 45, which is equals to y, which is equal to y upon sine 105. Now see, you can also use this logic for your sine positive thing. Now see, for example, it's 10 by, let me solve this thing first. So this is 10 by sine 30 is nothing but 1 by 2. I can write this thing. This is x upon 1 by root 2. And this is y upon sine of 105. So you can put it in the calculator. But this thing is, see, now cos of obtuse angle is negative, right? Cos of obtuse angle is negative. But what if here there would have been cos? So the answer would have been negative, which would have made no sense because the distance we are calculating, it cannot be negative. So here, that's why when it's obtuse angle, that time also sine is positive. So you can use that logic to understand that why sine is always positive, be it acute or be it obtuse. Okay, so now we can solve this thing. So we'll get 20 is equals to root 2x is equals to y by sine 105. I'll just write down that way. So we can figure it out that x is basically 20 by root 2 and y is 20 sine 105, whatever your answer is. So now you can solve, of course, to get the value. Again, they may ask you to rationalize. So you will get what? You will get 20 by root 2 times root 2 upon root 2. So which is nothing but 20 by 2 root 2. So the answer is 10 root 2. That's going to be your answer for this thing. Now, of course, for 20 sine 105, you can write this thing as 20 sine of 180 minus 105, which is nothing but 20 sine of 75. So, of course, you can put it in the calculator to get the value. Otherwise, also, you can put sine 105 in calculator and you can get the answer. Now, this was your sine rule. Now, what about cosine rule? Cosine rule, according to most of the students, is the most difficult one to remember, but it's quite easy if we use certain, just logic, sort of logic. Though it has nothing to do with that, but still we are going to use that logic. So anyways, so we are going to use cosine rule. So of course, cosine rule, cos has to be there for sure. Now, what is this cosine rule? So it is used when there are sides they have given a lot, but they haven't given you the angle. So generally it is used there. So let's figure it out. So it's going to be, let's say if we want to find the side, let's say a square. So first of all, it's based on square. Now see, a square is going to be what? Now, we need to find a square. So we are going to concentrate on b and c. Okay. And it's just a weird logic. So b minus c whole square is what? It's going to be b square plus c square minus 2bc. Right? That's it. That's all you need to remember. So a square is going to be what? It's going to be b minus c whole square. There's no logic there. It's just illogical logic. Anyways, so it's going to be b square plus c square minus 2bc. Since it's cosine rule, there is no cos there. So it's going to be cos of angle between b and c. Now, what is angle between b and c? It's going to be a. So it's going to be cos a. Now, again, let's get back to that thing. Remember, area of triangle. I've told you we have to give importance to each and everything. So we give importance to A, B, and C, all the three things. So here also we will give importance to all the three things. That's why B, C, and then A also. Again, it's just, there is no logic behind it. Anyways, so again, for B square, it's going to be what? Again, it's going to be A square plus C square. Just write A minus C whole square. It's going to be A square plus C square minus 2AC and cos of angle between them. So it's going to be cos B. And similarly, c square is going to be a square plus b square minus 2ab cos of angle c between them. Now, Let's take one more example based on this thing. So for example, if I want to find, if I need to find this C, and this is 10, this is 15, and this is 60 degree, let's say. So C square is going to be what? It's going to be A square, that is 10 square plus 15 square minus 2 times 10 times 15 times cos of 60. Now 10 square is going to be what? It's going to be 100 plus 220, 100 plus 225 minus 2300 cos 60, and cos 60 is 1 by 2. So it's going to be 325 minus 150. So C square is going to be what? C square is going to be 175. So your C is basically square root of 175. And that's your answer for C. Of course, if they ask you in third form, you have to simplify it further. This can be written as under root 25 times 7. So the answer is 5 root 7. So this is the side length 5 root 7. See, the thing is, we could have used sine rule. But the thing is, like, if we would have used sine rule, it's going to be what? It's going to be C upon sine of 60 is equals to 10 upon this angle. But we don't know this angle, and or it's going to be 15 upon this angle. But the thing is, we don't know both the angles, so we couldn't have figured out the value of C. So that's why we'll have to use cosine rule. So remember, cosine rule will be used wherever they will give you more number of sides. Like basically, see here they have given 2 sides and just 1 angle. On the other hand, if you see sine rule, they give you 2 angles and you just have to find the side length. Hope you liked this video and you got to know about this trigonometry well. So if you liked it, then please like, comment and subscribe the channel, and I would love if you share the video. Thank you.